These are our notes. It's going to be on page 78. We'll have to tape or glue this in. It'll kind of fit sideways to make it fit into our notes. This is SP3 notes. And we're going to cover a lot of topics here with this. So I'm going to turn this so that it looks a little better here while we're going over the examples. So this is talking about measuring variability and describing the overall distribution. So we're going to talk about those terms and how that works when we're doing these examples. So this says use the data points in the dot plots below to answer each question. Show your thinking for each question. So we know the dot plot, it has dots on it. The title says shoe sizes of 6th grade students. And then down here it says shoe size. We've got 4, 5, 6, 7, 8, 9, and 10. First question says, what is the range of the data? Well, the numbers range here from 4 to 10, but if you look at the dots, they range. There's somebody who has a shoe size of 9 and someone has a shoe size of 4. So range, we talk about 9 minus 4, the biggest minus the smallest, and our range would be 5. We know these are talking about shoe size of 6th graders because that's what the title says, so that kind of helps us out. Describe the overall distribution of this data. So you're kind of looking at all these dots here. The overall distribution, I'm going to kind of make it look like this. We call that a bell curve. Most of the data is clustered in the middle, so it's normal distribution or symmetrical. In other words, if I were to kind of put my pen right here in the middle, what's on the left of my pen is similar to what's on the right of it. They call that symmetrical. So the overall distribution, we said it was a bell curve. We call that normal distribution. I'm also going to call that symmetrical. All those words mean the same thing. We're going to talk about how the data is clustered around the middle. So if you were to find a good measure of center, you could use the median. If the data, which means like most of the points, that's what we're talking about, data, is clustered around the middle. I'm going to put middle / median because that's what median means, is the middle. Then I know we're kind of scrunching this on here. Then the median is a good measure of center. So median, I'm going to box that in, is a good measure of center. And the reason being is because most of the data was in the center. The next one talks about average June temperature in Maple City. So the temperature in degrees Fahrenheit looks like 65, 66, a lot at 68, 70, 74. We have one here out at 80. So what's the range of this data? 80 is our largest number that we have a dot on, and subtract from 65. We actually have several times where it was 65 degrees. 80 minus 65 would be 15 degrees Fahrenheit for the range. Move this up a little bit. And we're crossing off this. We don't have to do mean absolute deviation anymore. Describe the overall distribution of this data. Is most of the data here centered in the middle, or what do you notice about this data? Most of it's kind of over here on the left, and then it kind of tails over here to the right. So we call this clustered left. Most of the data is clustered to the left. Comma. It has a right tail, or some people call that skewed to the right. And the reason why it could be skewed to the right, if we were to add all these numbers up and then find the average temperature, 80 is an outlier, and so with it being an outlier, it's going to skew or pull the average up a little bit. If you didn't have 80 in the data at all, then the average temperature is going to be down here somewhere, but 80 kind of brings your average up. So there is an outlier, I'll put that in here as well, of 80. Doesn't really fit with the other pieces of the data. Explain why the mean is not the best way to describe the data in terms of central tendency. So when we talked about a good measure of center here, we said the median worked good. They want to know, why is the mean not good here? Well, it's just like we just said, if you add them all up and then divide by however many dots there are here, your mean is going to be brought up because of this outlier 80. And so mean is not good. Is not good. BC in my notes means because you have an outlier of 80. It brings the mean up, or like I said, to the right, which is to the higher numbers, which means it brings it up. That is not a good use or measure of center. Good, it's not a good use of center, or they call it measure of central tendency. It's not a good use of center. And we'll see that with your times as well. When I time you to come in and sit down, your average time, if you have somebody that kind of lingers to come in and sit down and one of your times is 80, but all the rest of the time it takes you about 65 seconds to sit down, and all of a sudden there was one time of 80, it's going to bring your average up. And so like if we just ignore that point, then your average would be brought back down or closer to where all your other points are. So that brings me to the other side of the notes. So this was kind of talking about describing overall distribution. Again, the dot plot shows some common overall distributions of data. Normal distribution, sometimes called a bell curve. So that's what we just talked about over here. Normal and a bell curve are very similar. We also call this symmetrical. Symmetrical. And so when you look at this one, it kind of looks like up, down. This is symmetrical. All the data is mostly around the center. The distribution could be described by the mean, median, or mode. In other words, if I say, what is the mode of this? What is the median? What is the mean? Well, how would you find mode? Mode means most. Which number occurs the most often? 9. Your median, if you add, or if you put these, there's 1 6, 2 7s, 3 8s, 4 9s, and you put all these in order, your median is going to be 9. Your mean, when you add your 1 6, your 2 7s, your 3 8s, when you add all these up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, there's 16 dots there. When you divide by that, your mean's also going to be 9. So this actually says average hours of sleep among 6th graders. If you look at this number of hours, looks like the average gets about 9 hours of sleep. When you're looking at this, I probably disagree with that. I would say a lot of our 6th graders are getting less sleep than that. Some of you may sleep more than others. So this distribution can be described by the mean, the median, or mode. It could be any of these, mean, median, or mode, because they're all in the middle and they all are the best measure of center. So when you have a normal distribution, mean, median, or mode, any of those would work for a good measure of center. So when you look at the next one, it says this is skewed to the left. We're actually going to call it clustered. Take off skewed, call it clustered to the left. Clustered to the left. In other words, most of it's clustered over here to the left, and so it tails to the right, or we're going to call it skews to the right. So we're going to call this one most points are left, or I'm going to call it lower end, and it has a tail / skewed to the right. And what do I mean by tail or skew right? So this one's talking about number of pets per 6th grade household, and then just having the number of pets. So a lot of the 6th graders have 0, 1, 2, or 3. Very few would have 5 or 8, really is kind of an outlier here. So it's kind of pulled to the right. So if I say what's the average, it should be somewhere over here, but your 8, your outlier, kind of skews your data to the right because there's somebody that has 8 pets. And then just the opposite of being on the lower end, meaning 0, 1, 2, 3, those are your lower numbers, then most of your data here is on the higher end or to the right when you look at these numbers. So these numbers are talking about 6th graders math quiz scores. So it's not skewed to the right. I'm going to call this clustered to the right. Most of the points are clustered to the right, which is good. If this is talking about math scores, then that means most kids are getting a higher score and there's few of them that are getting a lower score. So in this example, most points are right, or we're going to call this the upper end, and it tails left, or we call that left skewed. And the homework that goes with this is a card worksheet. So we will do a card worksheet with this homework. I believe it is a front and back.